Thank you for coming for the Ubuntu Tech Hive Saturday morning talk. Today, we're going to talk about Clickhouse, which is a high-performing column-oriented database, which is open source, but also have their cloud offering as well. I discovered Clickhouse, I think from then, maybe a year ago. And a couple of weeks, we decided that we wanted to kind of have a talk on Clickhouse, see how performs and intricacies of the database. So I kind of took about 10 days to learn the tool, and did some testing here and there. So the talk today is not gonna go obviously too deep into Clickhouse because that requires a lot more time and a lot more studying. However, I think from this talk we should be able to go download Clickhouse, query some files, write some SQL, and at the end there we'll also use Python with Clickhouse, and that's actually a neat feature that I actually had some fun using. So, and at the end we might have some LLMs as well. So that's kind of like the gist of it. So for those who maybe don't know what a database is, we'll get to the definition of a database. So what is a database? Database is a system that stores, organizes, and access information. It allows you to be able to, in a nice way, to access data. So for those who maybe have used Excel quite a bit, Excel is somewhat a database in a way, but it does not have all the functionalities of like your typical database. The reason why I say Excel is, you can think of it as a database because the way Excel is organized with columns and rows. A database, some databases, especially the ones that are relational, typically would have those kind of formatting, columns and rows. So what kind of database? We do have a few types of database. One that is called relational. So that mostly stores structured data with rows and columns, as I mentioned. And usually you will find those kind of databases where you have HR or CRM information. So HR, which is human resources, and CRM, which is typically your marketing and your consumer information, right? So what does that look like? So, an example would be you have in one row, like a person, like an actual employee, and then the columns would have maybe the employee first name, last name, age, salary, and so on and so forth. So that's kind of like how relational data is structured. And most databases these days are, I would say the databases when they first started, they were mostly that type. Eventually, we came into more non-relational database, which mostly handles unstructured or semi-structured data. And typically, those are used. The reason why we kind of have these kind of databases today is because of how the internet and the data flowing through the internet has created many types of data. So you have now videos, you have logs, you have images, you have sound like MP3s, you have documents like PDFs, So now you have a plethora of like different types of files, different types of data that also needs to be put in a database, and usually non-relational database are able to handle that. Any questions on these two? Right. So DBMS, which is database management system, like I said, it's the software that again allows you to define, create, and maintain and access your database. So they can be set up in a couple of different ways. So they could be column oriented, meaning the way the data is set up, it it focuses more on the columns of the table as opposed to the rows. So reading here, row oriented, for example, here, the data is stored by row. As I mentioned, the like the CRM, for example, or the HR database, everything is basically set up by rows. And usually the benefit of those kind of databases is mostly for allowing ways to do, how do I say that, figure out how to do like relationship between tables, for example. So in a database, you would typically have multiple tables. So one of the tables, for example, in an HR system would be employee table, and then you may have perhaps a project table, for example, or like maybe like a salary table, where the employee might, if you don't want to have the salary of the employee in the table, in the employee table, it could be in the salary table, and then it's joined that way to access the employee salary. So your typical, the reason why row-oriented databases could be good is because it makes it where it's easier to figure out relationships between tables, and it makes it where you're able to do joins slightly easier. But the problem with row-oriented databases, and we will see that later on in the demo, is that what it does is that if you want to query or you want to find some information in the database, you typically would have to go through every rows to find your information. Whereas when it's column-oriented, which the data is stored by column, read operations are typically, because when you're looking for data, you're typically looking for some information in some columns, not necessarily all information about let's say in one row. You're typically looking for maybe in one of the columns could be like salary, one of the columns could be age, one of the columns could be project, for example. You're typically looking for 3 or 4 information per row, whereas, and then when the database is column oriented, then you just read the columns that you need, whereas when it's row oriented, you would have to read basically every rows, which in turn will read every columns. Right? So we'll see that it's hard to explain but without a visual, but we'll see that in the visual later on. But just to reiterate again, row-oriented, it makes it where, when you're looking for the complete row, it's much easier that way. Whereas if, when you're doing column-oriented, it's much easier in terms of querying large data sets. Right? That's where your performance gain comes in when you have large data sets, meaning like billions of rows, but you only need like information into like 1 or 2 columns.
So a quick question: does it mean that the column-oriented databases are they still good to? I mean, is it still possible to do joins?
Oh, you can do joins.
Efficient.
Yeah, you can still do joins. Yeah, you can still do joins. Whether it's column or row, you can still do joins. Again, the beauty of column oriented is how, again, it's how it's able to not go through an entire table, for example, to find information, if that makes sense. That's kind of like the beauty of it. It's almost like a shortcut in a way. So if you look at this picture, for example, column oriented, so meaning, so if you look at the column for city, so you have New York, Los Angeles, San Francisco. Column for age, you have it here, name and ID. So that's kind of like how column oriented is stored. Row oriented is like this. So you would have it, I thought I picked the right picture, but maybe I did not pick the right picture. But basically what it would be 1, so ID, right? So it would be 1 John 30 New York. So you see, it would be all in one row as opposed to separated by columns, if that makes sense. So you see the boundaries here. So that means that's how the data is stored. Here, that one row, that's how the data is, sorry, like one row here. That's how the data is stored. So technically this row should be at the bottom and then row 3 should be at the bottom. It's not really supposed to be like in, so you can think of it as like row 1, row 2, row 3, similar to an Excel file. Any questions? Now we get into Clickhouse, right? So Clickhouse, for those who, and I'll show you the website in a second. It's an open source column-oriented database management system, and it's mostly used for OLAP, so which is online analytical processing. So it's when you want to do analysis for large amounts of data, basically, right? And you're able to do reports really easily. And it's having tried it, it's I would say it's fairly fast. Some of the features that it has, again, as I mentioned, is column oriented. SQL support, which is very important because these days SQL is, I would say, the de facto language used for querying databases. And you see it's able to handle petabytes of data. And again, it's good for analytical queries. Analytical queries, you can think of it as like analysis, where you're doing analysis, like, for example, trying to figure out sales for one region for a particular year. Those kind of like really precise queries. This is where these kind of tools really shine. So again, column oriented. The index is one thing that most database, if not all databases, uses. So index is a way to kind of put data together or categorize data together where it makes it easy to retrieve later on. So the way I understood index when I was learning database is to think about it in terms of like, how you have a book and at the end of the page, sorry, at the end of the page, at the end of the book, you have the, what do you call it? It's not the table of content. It's the words that are in the book, right? Like let's say you have a physics book, and then at the end you have things like volume at the end, right? Trying to find the information about volume, but you need to go to the end of the book, see, okay, which page that the reference of volume is, and then from there, okay, it's page 123, then you go straight to page 123 to find it. So that is how you use an index to find exactly where a particular data is. Because otherwise, what you would have done was to flip through the entire book to figure out and find volume, right? So that's the beauty of indexes. Indexes allow you to basically save in data retrieval by grouping the data in a way that makes easy retrieval. Any questions? Okay. So other I would say features, data compression. In any sort of databases, compression would be important because, again, we're moving such large amount of data that having data compressed in a way that makes it easy to move, let's say, through the internet or through your laptop, for example, makes it high performing. Another thing is vectorized query execution. I didn't get too much into this piece right here, but it's one of the features that that it has. If anybody has questions, you can let me know. I can look up more information about vectorized query execution and then let you know. And then finally, scalability, right? Anything that we're dealing with data these days has to be scalable and has to be able to use the resources in a way that makes it very, very efficient, right? So Yeah. So you would think that most databases these days would most likely have these features. It's the execution now that comes where you have to kind of like figure out, okay, is this really delivering what they're saying, right? Most people would say, hey, they can do column engineering, they can do the indexes, data compression. But once you have to actually try it to really see that it's actually working for your use case. So one thing that I want, if there's one takeaway for you that I want you to have for this talk today, is the way primary keys are set up in Clickhouse. First, what is a primary key, right? So primary key is you could think of it as like for a relational database, primary keys are a unique key that you have for a particular data or particular, let's say, row. So for example, let's say if we take the HR table, for example, a primary key could be employee ID, because the employee ID would be unique for the entire company, and they wouldn't have like any sort of duplicates in that table. So that is a primary key. And indexes, we talked about indexes. Now for Clickhouse, the indexes are actually, the way that it creates the index is it kind of groups data points, or here the Clickhouse calls it granules. And the granules are basically how many data you basically a logical, here at the definition at the bottom, logical groups of rows. So again, going back to Excel, because that's a nice visual, each granules would be basically 8,192 rows. So once you have data that fits the 8,192 rows, that is one granule, right? And then let's say you have 10 million records, then basically you'll be, in order to find the number of granules, you would do the 10 million divided by 8,192, and that gives you basically the number of granules in your Clickhouse database. Now, how they all work together. So when the query is executed, meaning when you do like select all from a particular table, which we'll see as a demo, then it'll go through the primary key to figure out which granule has that data. And then once you find the granule that has your data using the primary key index, then it's able to just look for the data or the information in those granules. And that saves a ton of time and a ton of like data processing that is great for everybody, right? For tables that are maybe 10 million rows, you wouldn't really notice that much of a difference because it's a magnitude of like milliseconds. But once you're dealing with petabytes of data, so like data from companies like Facebook, Google, which have like billions and billions of rows, it's a matter of like running a query for 5 minutes versus maybe 30 seconds. So that's a big difference, right?
So I have a question. Why 8,192? Why not 10,000 or 6,000?
Just about to ask the same question.
Because it corresponds exactly. I think if I remember, it's 10 megabits of data, if I'm not mistaken. I gotta look one second. I remember I saw it this morning. It's about there's a reason for it. It's I think it's 10 megabits of data or something like that. Give me a second, I can find it for you. But there is a reason.
Yeah, but so what does that do? If it's less than that, then what happens? It doesn't work? Or if it's higher, does it work faster? Or what's the deal?
What do you mean if it doesn't work? Like if the granules, if for example if it's like higher than the 8,100.
Yeah, or less. Well, then what happens?
Then it suffers. It suffers efficiency because the way they set it up, I think it's right here. The way it's set up with the 8,192, that's how they were able to figure out that that's the most efficient way to group the data by, for example, in a granule. So I think I found it.
And why are you asking that also? Is that a fixed number or that can be changed as well?
It's a fixed number.
Okay.
Yeah. It's a fixed number. There is a reason for it.
Yeah, but it says default. It means we can change it, right?
What is it default?
It said default 8,192. So it means we can change it, no?
I don't think you can change it. I think the default was maybe like a mistake from my part, but no. Let's see. Okay, I can't see where the actual reason for, but I know it's because of how much data actually that granule, the 8,192, how much data that actual granule is. If that makes sense. There is a reason for it. I'll put in the chat, there's something about the primary index that could be helpful. There you go. Any other questions? Okay. Okay. So Clickhouse has what you call an engine, which is basically what it's used to do certain operations within the tool, right? The one that I used quite a bit was the merge tree engine, which is the one used to do most of the operations, loading data, partitioning and figure out like primary keys and things like that. So right here, that's the merge tree engine. They also it also has other engines like replacing merge tree, summing, aggregate, collapsing, version, and graphite. I didn't have time to actually go too much into these, but basically, whatever you're about to do, these are I would say kind of like configuration when you're writing your queries, right? So most of the queries that I tested out, the configuration was using merge tree, like loading the data, reading data remotely, just running basic queries. We use the merge tree. For other use cases is where reading about and knowing about these other engines will allow you to really fully get the power of Clickhouse. It's also, in terms of integration, you can use Clickhouse with MySQL, for example, MongoDB. You can read files through HDFS. I use a lot of S3. A lot of the files that I use were actually stored in S3, and you can use it with like streaming, like Kafka, do like streaming with Kafka, for example. Okay.
Oh, so you mean that a SQL database can read from another SQL database?
Where is that? No, the integration. So basically, like how it's integrated, you're able to set up Clickhouse to have a connection with MySQL and using that app to store.
And query it, no?
No. MySQL, you can only query MySQL with MySQL. The way the integration engine is, you can use MySQL to basically get how do I say that? You can get MySQL to be able to do Clickhouse queries, but MySQL is a separate entity, right? MySQL is a separate database. You're not necessarily able to do. Actually, no. From Clickhouse, you're able to integrate MySQL because you have how do I call those? The connectors, right? The library connectors to query MySQL. Does that make sense?
Yeah, okay.
So let me show you integration engines. So Clickhouse. Sorry. Right here. So here. Put it in the chat here. So you can, let me share this part. I'll share this screen. So see the integration, right? So Clickhouse, the MySQL engine allows you to do select and inserts, right? Stored in a remote SQL server. So yes. So Clickhouse, you have a connector with MySQL, and you're able to basically query MySQL directly.
Yeah, actually, if you scroll down a little bit, I think they even show where it connects.
Yeah.
I think, let me see. Yeah, if you scroll down a little bit more, the next, yeah, that single line code block, scroll up. Yeah, this one. So
Yeah.
I can see like MySQL with the default port 3306.
Yep.
Yeah.
And then the engine. Yeah. So it's
That's really cool. That's really cool.
What's that?
I said that's pretty cool.
Yeah, it's pretty versatile. I didn't test out this particular one. I did a lot of S3 local files. But yeah. You can see on the left side here, you have a bunch of other, I would say, storage places where you can query data directly from. So Azure Blob Storage is one of them. As I mentioned, S3, Postgres. Yeah. All right.
So another related question.
Mhm.
So with these integration engines, right? Okay, is it possible to add data also through these engines, or is it just for reading?
That's a good question. Well, let's see here. Yeah, so it allows you to do inserts to the SQL server. So now for example, for S3, I'm thinking, okay, if I'm able to read from S3 like a Parquet file, am I able to maybe at the end of like a SQL query, for example, create a Parquet file? The only thing I can think of is maybe with Python, right? When we do CHDB towards the end, when you read from, let's say, a Parquet file using CHDB with Python, you should be able to write back using Python with the wrapper, obviously, and then store back as a Parquet. So that way, I think that would work in S3. I don't know if you're, well, here you can insert for sure, but for the other ones, I'm not 100% sure. But if you're able to read, let's look at another one. Let's look at, for example, S3. It doesn't say. MongoDB maybe, or which one would be a good one to look? Maybe Postgres. Let's see. Yeah, Postgres, you can do inserts too. Hive. See, so for Hive, you see, it only allows you to do, it says, mention allows you to do select on HDFS tables. But I suspect for HDFS, the file system, you should be, I do think you should be able to write back, but probably not directly. You probably have to use like I said, CHDB, for example. That's the only way I can think of it. Yeah.
Yeah, because the first thought that came to mind is that if we can write back using those integrations, like I mean, it would be worth exploring how fast it is if it can support an application with a certain amount of traffic. You know what I mean? Like maybe running Clickhouse close to the app, and then it can insert and read back from S3. That would be cheap to run, I think.
Yeah, let's see. Yeah. Yeah, that would be
Oh,
good.
I just saw an insert, like when you.
But it's
Yeah,
an
insert.
Yeah, but you created the table. You're not inserting into S3. You're inserting into the table that you created from the data in S3. You are talking about actually inserting back into S3, right?
Right.
Right. No, that's not it. So here you're just creating the table and then loading from S3. Sorry, you're creating the table, then you are inserting the data into the table in
the same table, no?
what's that?
It looks like it's inserting into the same table.
Yeah, but the table is not in S3, right? The table is, I mean, S3 is a file system, right? So that is just the.
Okay.
Yeah, your question is like, are you able to store back in S3, right? Are you able to actually create a file in S3 from, let's say, that's not it. That's this right here.
Okay, got it.
Okay. Shoot. Let's see. Stop sharing now. All right. So, okay. So I think now we can get going with the kind of like the demo. And yeah, so let me share. For those you can follow with this right here. Now I'm gonna just kind of switch to the demo. Can you see the terminal?
Yeah, but it's
Yeah,
hard to.
you can see it.
You can see the terminal. Is it small?
Yeah.
How do you even increase the screen? Is it Command plus? Yeah. Is it better?
Yeah, a bit better, but I don't know if it's the font, but it's not very legible. At least the stuff that was printed at the top.
Oh, don't worry about. So let me do this, and then I will do. So I had already downloaded Clickhouse just kind of like following the command curl, Clickhouse and then Datasets. Now,
yeah, maybe if you make it full screen, maybe.
okay. Let me make it full screen.
Yeah, then you can do Command plus again. So.
Is this better?
Yes.
Okay. So so basically you can see the first one is the install the library, simple. Then you run the server, which opens up, the actual database server. And then the third one, and I'm realizing it's all say step one. So you did 1, 2, 3. And then the last one is the client. So the client basically allows you to connect to the database. And you can see we connected the database. I have the what do I call it? The server running here. If it's actually running, actually it may have been stopped. No, it's running because it's right here. So the server is running here, but we don't need that. No. So let's see, we can do this command will work. So show database means that it will basically show all the databases that are present in the now my SQL skills are showing. I was trying to show all the databases that are present in this sorry, all the tables that are present in the database. That's why it's not working. So show tables. Yeah. So I have a table that I created earlier, so that's why it's right here. You can see. So the table in the database that I created. So I have a table called one time. We'll talk about it soon. Now, the first thing I want to do is this, right? So we have a file in S3 that Clickhouse provided for kind of like the training. If you look at the query, there's a query that I don't know if you can see. It says in the gist, select all from S3, which I'm gonna paste right here. You can see, and then we'll talk about it. So this is the query. So select all from S3. So S3 here is kind of like the function to read data directly in S3 from Clickhouse. So again, we are in Clickhouse local, meaning Clickhouse is is spin up in my machine, my computer, my local computer. The file is stored in S3 somewhere, probably in US East 1 or something like that. Could be in Russia too, actually. And I'm gonna query the file directly, meaning I don't know if you can think about this. I'm actually using SQL to query the file. So I don't know what the file looks like, but I can query the file directly because before what you would have to have done is go download the file, unzip the file, maybe import that into maybe Excel or something in order to actually see the data or manipulate the data. Here, with just this command, select all from S3 and then the path or where the file is on S3, I can directly query it. Limit 10 means I don't want to read I don't want to display the whole data. So now what it's doing, you can see, it went and got 10 rows. Apologies, it doesn't look as great because it's a lot of columns. I think it's 170 columns. Maybe what I can do, I can maybe pick one column so you can see what it will look like. If I can find like an interesting column here, maybe this one. So what we'll do, well, I can never figure out how to go from end and back, so I have to do this the old school way. So I'm just gonna query one column.
Control A, I think.
Control A.
Yeah. I
So
think
this.
it works in the regular terminal.
Okay. All right. So now you only got the one column, right? So we just say, hey, give me the ITA code reporting airline. So ITA code reporting airline is, for those who are aviation enthusiasts, this is for Delta Airlines. So when you see like flight number DL173, for example, that's what it is. So it's like an international code for all airlines. So that's what I called. So got 10 rows. And again, I want to reiterate that the file is not here. The file is actually in S3. If I want to see how the file, how many rows there in the file, I can do like a basic count. You can see what it's doing. It's slow because it's actually doing a stream from S3 to my computer and trying to figure out how many rows there is. This is gonna take forever because we only have 3%. So I don't have time. We don't have time to go through all to that. So that tells you that yes, you're able to do this kind of operation from a remote file. Two, this file is pretty big because I think it's about 200. Actually, it's modestly big. It's about 205 million rows. But because the file is remote, that's why it's slow like this. So I'll kill this. But it's about 205 million rows. So I kill the command because it was gonna take forever for us to get to the end. Same thing with this command right here. Actually, no, I'm not gonna run this. So I had like a, how do I say that? Like a another query that I ran, which looks like this. Can you see the gist? Gist? Can you guys see the gist?
Yeah, it's in the link is in the comments.
Yeah, but you can see the page, right? You can see what I'm highlighting.
Oh yes.
Okay, because I don't know if it's showing the terminal or just, but okay, so you can see this right here. What this is, this query again is querying the file directly, right? I was trying to figure out in 2007 what are the airlines that were late more than 10 minutes, right? So basically that were late. And this query I ran it last night, it took about 420 seconds, which is like, yeah, I can't do math this morning. So you see, you processed 204 million rows, and it took a while. So I waited for a good while for the response. But here's the response. The airlines that were late, I don't even know what WN is. Anybody knows which airline this is? But this is American Airline, and this is US Airways back in the day, and this is United Airlines. I can't remember what NQ also is. Those are probably some old school airlines because this data dates back from like the 80s up until 2022. So it's great that you can query files directly out of S3, but as you can see, it can be pretty slow, especially if your internet is not fast or your laptop itself is not fast, right? So,
yeah,
right.
So it looks like Southwest, I think.
Which one? WN?
Yeah, is that right, Akuma?
Yeah, I don't know.
Yes.
Southwest. Okay. I don't fly a lot of Southwest. That's probably that's why I don't know. Okay. All right. So then what I did, I created a table. Sorry. Apologies. I'm gonna bring this back again. So what I did, I created a table called on time, which is the airline table, and these are all the columns and the data type. So these are Clickhouse data types. I need to get familiar. I mean, there are some data types that I'm familiar with, some that I may not be familiar with. Like, for example, I know this is a string, integer, but yeah. So basically, this is inferred. Inferred meaning that Clickhouse looked at the data and decided that, oh, this data looked like it's an integer, so it inferred it as being an integer. You could yourself provide the data types, so that's something you can control by just changing it right here. Remember what I was talking about, the merge tree? So the data is going to be inserted using a merge tree, okay? One other concept we talked about is primary keys. The way Clickhouse creates primary keys, indexes, is you actually create it in the order you want, in the order in your order by, or basically here it means it's creating an index where year is gonna be top level, then quarter is gonna be the next level, month is gonna be the next level, day of month, and then at the end airline, right? So it's gonna create the index using these fields. Again, these fields are in the column. So if we look at year, for example, year should be somewhere in here. If I can find it, right here. See, year is right here, right? And if you notice also, it's the first column that came in right here. So that's another feature of Clickhouse, apparently, that if you put the column kind of at the top, it's sort of inferred that it's all, it's the index. But the best way is to do it right here, right here. So as I mentioned again, the merge tree, see the engine. What this would do, which I would show you later, is speed. And we'll in the subsequent demo I'm going to show you, but keep that in mind. Okay, so I created a table. It's called on time. There was too much data to go through the wire, so I just kind of loaded about 1 million rows for just 1 year. So that data is there, and then we can do a simple query. One thing I wanted to do, we can do, for example, select count from on time. Do you guys remember that I had a table called on time? So you see, I have 1 million record in there. So, and again, on time is a table that I created using that command, create table, and then I pulled about 1 million records from that S3 file and I put it into that table. And a simple, quick query that I can do to show you the airlines that are delayed for that 1 million rows. Oh, sorry, no. So basically what this query is, which airport kind of has the most delays you can think about, right? So ORD, which is Chicago, DFW, I think that's Dallas, Atlanta, LA, Los Angeles, Phoenix, Las Vegas, Denver, Boston, St. Louis, and Detroit. So these are the top airport where there's a lot of delays. And for those who are aviation enthusiasts like I am, so these are actually airline hubs. So that's why there's more delays there, because usually you have the airlines go there, to do their to feed that hub, and then they can fly to smaller destinations. So the traffic in these big airports are a lot more traffic there, so which in turn create a little bit more delays. Okay. The other way, any questions? Okay. I also played around with another file from the New York, the complaints from the New York Police Department. I did some of that work earlier. I already downloaded the file as a TSV, and I'll show you how to do that later. And basically, the file is locally now, meaning again, now it's a different scenario. Before, just to reiterate, before the file was in S3, and then I loaded just about 1 million record into the table called on time. Okay, and then I did my processing. Now it's the whole. Now it's a different data set called NYPD complaints. You can click on the link. You can see the file, the data set. Now it's not a. This file is not. I did not take a sample. It's the whole file, and then we can take a look and see how it kind of performs in a way. So let me describe that table. So I have to always copy because if I have to type, it's going to take forever. So we'll describe, but I need to change something here. So the files are located in my folder. So you can see what the describe command is. It's asking the table or the file. Sorry, we haven't created a table yet. Now we are directly querying the file again, and the file is a TSV file. It's saying, hey, tell me what the files look like. Give me a description of the file. So describe. It says table here, but it's technically reading the file directly because we haven't created a file. So you can see these are the columns that are in the file for that NYPD complaint data set. You can have here, I think this is the address. There's patrol borough, New York, if they're boroughs or their neighborhood, I think is how they call it. And then this is the offense. And this is the column that we're interested in. So basically, this is what kind of offense happened for that particular complaint. To know that, we will run. But before we do that, we'll do a select all to see what the file looks like. Any question while I'm doing this? I'm gonna do a select all. Oh, you said Control A, right?
Yeah.
So we'll do a select all from this file. And then we don't want to take everything because it's too much. So we'll do a limit. Again, this is a best practice for you when you're working in a company, is to always give yourself limits, because otherwise actually select all is not always the best way to query data, because you might be pulling data that is unnecessary, but it's a demo. Usually doing a limit might help, but the best way is to always pick the columns that you want. Or if you're using like a tool like BigQuery, for example, you can do the preview data. Then it's not actually reading, it's not actually doing a query that might cost you money, if that makes sense. So sorry, the data is kind of bunched up, but this is what it looks like. So we pull the data and, yeah. All right, so I have a better query that I can show you. Just give me a minute. So this right here. So this is kind of like the type of complaint. Actually, which one do you want to see? Do you want to see the number of complaints by crime type or the most common crime at night? I'm leaning towards this one. Most common claim at night.
The most common crime.
Yeah. So I have to update this query because right here it's actually pulling straight from the data. So give me a minute. I'm gonna clean that. I'm gonna fix that. Pull it from a different from the current table. So just give me 1 second. I have to update the query, because as you can see there, it's using the URL. It's actually pulling it directly from the remote file. but I have the file in my local, so I don't need to do that. But if you want to run this query should work. Actually, but you need to download Clickhouse first, right? So, all right. So let me run this. Bear with me. Hopefully the query works. Of course, it doesn't work. That's why. Oh, I know why. I made a mistake here, but here's the it should work now. Yeah, of course it doesn't work. So it's probably complaining because, oh yeah, okay. When I downloaded the file, the local file, I've kind of have had some issues with it, especially because of maybe the way I downloaded the file, there was some corrupt data in there. One of the things that you would run into when you're dealing with files and loading files into tables is like issues with null into your records or some bad data in that data set, and you have to write logic to clean that up or find ways to clean that up so you can run your queries. But that's fine. I'm just gonna run this one. This one should work too. Hopefully it doesn't take too long. But in the meantime, so it's doing the processing. So in the meantime, do you have any questions, or I can get the next step would be we'll start getting into Clickhouse Cloud, which is actually where you can have like a hosted version of Clickhouse where you don't have to do pretty much any of the downloading and anything that you do it. They have everything set up for you.
So sorry if this question already came out or if you discussed it. But what are the hardware requirements for using Clickhouse?
You mean locally or like a hosted version?
Well, both. Because even if I usually do dedicated servers, so if I want to have it on a dedicated server, like what are the specs that I need?
I don't. Clickhouse is not. It's not, from what I can see, it's not a very heavy binary. It seems very light in terms of how big the engine actually is. My laptop, it seems fine. I downloaded it, it was pretty fast. So I'm thinking, I mean, if you go into production grades, if you want to do like production grade work, probably having a little bit of a beefed up well, you may not necessarily need like a beefed up machine to start with. Now it all depends on like your use case. So if you want to do like a dedicated, like meaning you want to spin up your own EC2 instances, for example, from Mara, you should be able to just like medium size to start with, and then if it's like let's say not enough, then maybe increase that. But in terms of whether you need let's say complicated hardware, I haven't, from having worked on this for like this, I haven't seen anything. But they have a cloud version that there you don't have to worry about anything. But then again, you might pay more. It's not,
yeah. Go ahead.
no, I was gonna say it's not a very exact answer, but from reading, I haven't seen anywhere where they say, hey, you need to have like supercomputers or anything like that, if that makes sense.
Thank you. The reason why I asked is because I did a quick search on Google, and then it says that you need a minimum of 4 GB of RAM. Otherwise, some of your queries would get aborted. So that's why I wanted to see if like you
Yeah.
came across like something that is better, or if it's just fake information that I'm reading.
So which is so 4 gig of RAM, unless it's me, like I feel like most computers have like double, if not triple that already, right? So
That's if you're not paying for cloud.
exactly, I know. Yeah, so that's why I said, you know, it's one of those things, because I think the reason maybe it needs like at least that, it does, you know, parallel. Reading it, like I saw some things about doing things parallelly. So yeah. So yeah, I don't know. I think, you know, having used it on my laptop, the only limitation that I saw was when I was trying to do the streaming straight from the Parquet file. But when I was using the cloud version, obviously I was not paying for it yet. That was fine. Yeah. Any Ben, did you want to say something?
No, I was curious, like in the case of the self-hosting, like what does the download look like? Is it like a single file, or is it like a folder structure, complicated? Basically, I'm trying to figure out if we need like a Linux package manager to install, or we can just download a single binary.
I think you can download a single binary. That's what I did with mine.
Okay.
But again, anything that's production might be, you know, the dealing with that might be different, right? But yeah, it's just, it looks like it's just a simple binary. That's all I had to download.
Okay.
So our query finished. It took about 82 seconds, so a minute and some change. So the most crime at night is petty larceny. Is larceny theft or is larceny fire? I can't even remember. Petty larceny, harassment, assault 3, felonies, and traffic laws, robberies, current larceny. I think it's theft. Yeah. So our query came back. All right.
Okay.
Any questions? Okay. Now we can go to the Clickhouse cloud. This is actually should be here, but Clickhouse cloud is right here. So basically, this is what it looks like. Can you see the console?
Yeah.
Yep.
Okay. So I'm just gonna like show you because I didn't want to close my stuff. So I'm gonna have to wake the service up. This is a free version that I've been using. And basically it reminds me of BigQuery in a way, where it gives you that nice interface, where you can see your data sources. For example, you can set up ClickPipe, which is a kind of like an ingestion tool to pull data into the platform. So remember the on-time data set and how I mentioned to you that it's a massive file. So yeah, it's about 10 gigabytes, 204 million records. I loaded that today. So you can preview the data right here. Yeah, so you can preview the data right here. So all this, you know, like you don't have to like do all the crazy SQL on your terminal. You know, it's right here. It's nice and clean. To create an ingestion, you just have to do like get started, and then you have these connectors right here. Cloud storage is the Google S3 version, and then your Amazon S3. I'm surprised I don't see Microsoft, unless, anyways. So if you click on S3, for example, then for public clouds, you just have to select this one that says public. You provided a name, and then you paste that link, right? The where the file is located, right? So for example, for what I've been doing, it will look like this. So the airline data would look like this. So you would do it this way. And then you do incoming data. I don't want to click on it because I don't want to ingest it again, but actually maybe, no, it's on time too. I hope it's not going to create. Okay. So you can see it was able to look at the file, and then it tells you all the individual files that are on that in that link right here. So you can see here you have CVS by year, and then you have that star. That star means that it's gonna pull everything, because the files are individually stored by year. So 87, 88. So it's gonna pull everything. And then if you do parse information, I think it's gonna do the columns. Okay, so it's complaining about something. I think, oh, yeah, I know why. You need to change it to CSV. Then do it again. Okay, so now we infer, as I mentioned, we infer the column names and also the data types. Also, it didn't infer the column names; it inferred the data type. The columns are already there in the CSV as the top row usually, and you can see all the columns. And if you like them, you can keep them or you can change it yourself. Like as I mentioned, you can pick whatever you want. You can also add some columns, and then details and setting. But the interesting thing here is a couple of things. Here you can change the table name. I'm just realizing that because yesterday when I was doing it, I hadn't seen this, but you can change. You can actually change the name here to put like the table name. For example, as I mentioned, you can say on time table or something. And then I stored it in a default database. Yeah, so that's how you create an ingestion job, a click pipe. So I already have that here. I did that last night, 204 million rows. Now we can go to the console. So now we can kind of like start querying the table directly. So I don't know if you remember, again, my apologies, but this is kind of like the table name. If you think that's this right here. So if you run this is just now just kind of like easy. You just select this and then you run the query. So same results. I think he said Southwest. So now it read the whole data, right? So 707 million. How do I say that? 7 million instances of Southwest being late, more than 10 minutes. So that's for this query. We already seen that. We can do. I'm gonna skip this one. Now, what I wanted to show you earlier was the whole thing about primary keys and how it's important. So here, I loaded the data without doing anything. I did not do any sort of like partitioning or indexes. I just loaded it, right? Because it was that click pipe job. So what I said now, I want to know, average lateness of airlines between 2000 and 2002, and group it by year and order by year. So I want you to pay attention to this. Pay attention to this. So we read 204 million rows. So basically we read the entire table to just figure out something for 2 years. Okay. It took about half a second, right? 0.433. Now I created another table called on time. Again, if we go back, we pulled it, we created this one. This one was from the ClickOut job that I showed you. I created another table here, and then same data, but this time I did a order by, which basically triggers the index, which create the index by year, quarter, month, whatever, which I mentioned to you earlier. So the table is created, it's right here. Then I loaded everything right into that table. So insert into on time, select all from this. So just kind of like to see, hopefully the demo gods are gonna be with me today. I'm gonna count from on time, and we should have 204 million records. If we don't, I apologize already. Wait. Oh, count. Yep. So you can see we have 204 million records. Okay. So the two tables are the same. The only difference is that one has the index and it's partitioned, the other one doesn't. Now, same query. Now we're pulling it from here, right? From this table instead of like this S3 one. Same query. Now let's see how many data or how many rows it's going to read. We only read 16 million because of the way the index was created. Same query, same table, just I created the index. It read 16 million rows as opposed to 204 million rows. That is a big, big difference and a lot of money saved for you, if you're using the cloud. So as a database administrator, when you're creating tables, talking to your end users and figuring out like how the table is going to be used. Are they going to be doing queries where they look at the year, where they look at quarter, month, especially they're going to look at which airline it's about. Then you're able to create the indexes based on those so that the most common queries are always going to filter on those kind of like columns, and you're going to read much less data. Any questions?
Is it safe to say that so far I've seen that it excels at querying data, but because of the injection part, is it safe to say that it's now really good for CRUD, like create and deletion, update and all that? It's more of like a query, like read only.
So I'm gonna use my experience as having worked with data to say that, and this may require some checking, but typically when you're dealing with data warehouses, right, and these kind of databases, a lot of times because you're doing more analysis where you actually go in and getting the data, right, and you're doing how do I say that, analysis, figure out like doing calculations. A lot of time it's more, hey, let me go get the data and figure out the answer. Then the performance is going to be biased towards read operations. You can definitely do updates. So you can really do updates, deletes, and all that with these. But I see more relational database be much more performance with those updates, reads, because of the frequency of updating that data, right? So a lot of times when you're doing how do I say that, sales data or whatever, like a lot of times you are doing a lot of CRUD operations, right? Whereas here the data is already it's already there, it's the end user data. Then mostly you're doing how do I say that, read operation. So this is me and my experience saying that, but it needs to be verified, if that makes sense. Yeah,
I see. Because I was thinking when you were talking about it, I was thinking about like Merch BI. I don't know if any of you guys are familiar with the merchandising area. It's like Merch BI is like a Microsoft tool that allows merchants to actually have like big data and do a lot of like reporting with it. But the data also does get updated. So, I was thinking about, okay, this could be a tool that can actually, that a Merch BI team can benefit from. But the more I'm going through it, I'm like, okay, this is more like a middleware than actually like a custom database that can solve the problem.
Right. Yeah. For sure, I've explored my exploration. I've done a lot of the read operations. And until Ben asked about storing, how do you like store back the data? That I was like, oh yeah, that's another thing that is important. So, but yeah, I can't say that this would be great in doing a lot of like updates, a lot of upserts and things like that. I would anticipate that maybe not, but for sure read operations, it seems to be very good.
Thank you.
Yeah, thanks. Yeah, any other questions?
Yeah, but I have a related question. So this can be used as an analytical database, right? So I'm assuming it should be, I mean, if that's the case, then it should be good for, let's say, like time series data. You know what I mean? Like a bunch of events happening, and then it needs to be inserted, like keeping track of time. So in that way, it should be at least decent for inserting data, right? In the large volume.
Yeah, you IoT, you're able to do IoT, which is, Internet of Things. Sometimes that looks like almost like, could look like time series almost. But yeah, I mean, I think maybe what I failed to say, it would definitely be decent. I think maybe the physics question was more like, can it compete with like maybe something that's more suited for those kind of crowd operation, if that makes sense. Yeah, it can definitely do it. It may not be the best, is maybe what I was trying to say. All right, so that's all I wanted to show in Clickhouse Cloud. Maybe this last query we can run. So basically, this query, most popular destination by the number of directly connected flight from various sphere. So in any, basically this query is telling us that these destinations have a lot of like one-way flights to them, which makes sense because again, they are hubs. Yeah, most of them are hubs. So, all right, any question on this? Again, this was pretty neat. I like the cloud one, but this is mostly good for if you want to do ad hoc analysis. You could also do, if you don't want to like mess with installing it into your machine, you can use this. It's free for $300. I think they give you $300 credit, but I don't know how much after that you may need to definitely pay, especially if you're going to be dealing with like massive amount of data. All right. Final part is we will talk about CHDB. If I can find. So CHDB, the way I even understand CHDB is it's like an in-process tool that you use with Clickhouse, which integrates Python, and you're able to do processing with it. That's kind of like how I can explain this. So it's serverless, meaning you don't have to install anything. You just need Python. You need like programming languages like Python, right? Go. The one that I'm gonna demo is with Python. I think these days you can now do Go, Rust. I haven't checked those yet, but yeah. Ben, when you were talking about reading, about storing, I think, again, if you're able to read Parquet file, you should be able to store also with the Python syntax, using the SQL. The nice thing about CHDB is that now you can use Clickhouse with tools like Jupyter Notebooks, Google Colabs. I use Google Colabs. We'll go through that. You can still process a large amount of data, but now you have the power of Python. for example, again, I keep saying Python because that's what I use, but you can use other languages as well. And as I was thinking this morning, you can actually do data pipeline now, because if you have Python, then you can like put your code together to maybe do like a ingestion step, and then when that step is done, call another Python function to do analysis. When the that part is done, call another function to do like the storage version. So basically, you're creating a data pipeline just using Python. I haven't done that, but you should theoretically be able to do that. Well, all right. So let me show you. So in 1 second, I need to drink some water or tea.
A good question. Is it possible to make your notebook public?
It is. It is not.
No.
Oh, maybe it's not. How do I even hold on? I hope, yeah, okay. If it's public, hold on, give me a minute here. If it's public and someone see the keys, because I have some API keys in there, but I'll make it public right now, and then you guys can see, and then I'll remove it. So done. If you look at, I'll share the notebook with you. Be able to see it now. Okay. So we'll do a CHDB demo. Again, as I mentioned, we're going to use Python. So I'll install CHDB using pip, just the Python library. And as it's doing that, I want you to pay attention to here. Okay. So now, because now you have the power of Python behind you, so when you import the module, now you have functions like chdb.query, and then you pass this query right here. So if you remember again, sorry, this is a different data set. I've used like 4 or 5 different data sets here, but you pass the query. So select all from, again, it goes back to S3, reads this Parquet file, and then gives me the top 5 basically records for those. So I don't know if you can see the, I guess, power here is you have SQL queries embedded into Python code, basically. And if I run it, right now it's running this right here. So it's pulling the data remotely. And then here's the response. So price, date, postcode. So this is kind of like the what the data looks like, the first 5 rows of that data set. Similar to this right here, now I'm looking at like the top 5 towns in the UK. If I run that, it's a little bit more of a complex queries. You can see you have more like a group by, an order by, an accounts, and a top 10. So you can see the top 10 town. London makes sense. Manchester, yeah. So again, you have Python, which kind of wraps SQL queries. And which makes it interesting is that you can now start doing like visualization directly, right? So here we're doing how do I say that? We're looking at prices, the average price of houses on a yearly basis, where in London, how price change in London basically throughout the year. And again, you can see it's really interesting because you query it right here using Python, and you can straight up plot it directly in the same kind of like piece of code. The other tool that you could use to do that is Panda, if I'm not mistaken. I haven't used Panda in a while, but Panda, you could do that. But the Panda does have some limitation in terms of like how big certain data set might be. Whereas here, you have the power now of Clickhouse, wrapping it around Python, right? So that should give us the prices of houses, year and a year per year basis. So it's slow because again, we're doing the remotely looking at the data. So let's see how long this is going to take. But while this is running, I also, if you remember, we did the delays for the airlines, and I'm going to plot that as well. One interesting syntax that I kind of want to mention is this syntax right here. Remember when I was showing you all the different files? So like 1998.csv, 99.csv, blah, 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 blah. This syntax right here basically says, only give me the data, the files from 1995 to 2002. So those brackets, ... 2002 would give you only those files. This is taking a very long time, but that makes sense because it's a big file. Any questions before this ends? Nothing in the chat? Okay. All right, so we'll let this one run. I will start talking about a little bit of LLMs that I tried, and then we'll come back to this and see what it looks like. Okay. So I use OpenAI to I wanted to see if I can have OpenAI basically create queries for me. And I think we've done this many times where we've had LLMs create queries for us, right? I think Ben has done a lot of talks with that. Derek also did something where he used some tools like that to create queries for him. So I wanted to try that. So for those, basically I install OpenAI library, and I have like this little function right here that says that, it's basically to help me build a query. So it's quickly, this is what I'm going to tell OpenAI LLMs that, an expert in OLAP databases, can create SQL queries. He, very well versed in Clickhouse. And then I told him, make sure that Clickhouse compatible, because Clickhouse syntax is slightly different sometimes from like your typical SQL syntax. So no tables in memory, load files using this file function. If it's a URL, use this one. If it's if it's located in X3, use this one. Basically, kind of giving it a framework to use. And right here is the question. I would like you to generate an accurate Clickhouse SQL query for this question. Okay. So we have this function here. Now here is the question or the query. Now I say, show me the top 10 towns from the URL, this one, okay? And then I tell it to build, I have that prompt, and then I tell it to build that query for me, okay? All right, let me go take a look and see if, oh, yep, it finished. So you can see, this is what it looks like. I'm gonna run this one too, and then we'll go here and continue. So we'll build that query. So what this is doing, it's creating that prompt. First, creating the query, show me the top 10 towns from this URL. Then it's building, it's sending that prompt to build the query, and then calling. I don't know if I can't remember if it's now called out. No, the caller for OpenAI is at the bottom. I'll call it afterwards. So right now it's just building the query for now. And the reason why it's taking time is because I think it's because it's busy with this one right here. I should have stopped this for now. Yeah, that's the thing about OLAP is that you can't run. You may not be able to run multiple cells at the same time. But it's only 1995 to 2002. It's not, shouldn't be too bad. I'm tempted to stop the other one and then run this. But anyways, all right. So when this finished, basically I'm gonna pick up that prompt and then basically run it here, because we've done these talks many times where you have the OpenAI client, and you're using GPT-4 Turbo. This is from an old talk, so don't worry about this. It's repurposed code. So right here is actually again telling the AI to make sure that it stays within Clickhouse, and this is the prompt that was going to be built at the top that I'm going to pass, and then we should be able to see the answer at the bottom here. So it's still not done. Any questions before this finishes? Any votes for me to stop this, or are we too invested for right now?
You can continue.
No, I mean to cancel this. I mean, it will look like this. You know what? I'm gonna cancel it.
It's a bit.
Yeah. Hold on. That's what you said. Okay. So I'm gonna run this. So that's ran. So that prompt is ran. Wait, what happened? Oh, I know. Run this. Okay. So the prompt is ran. Now we're gonna do this, which should give us the query. Oh, my bad. OpenAI is not. I thought I did right here. Why did I miss? Okay. So he gave me the query. So I did not write this. You see, he gave me the query, which is again the top 10 towns. And then let's see if it works. So if you remember at the beginning, I don't know if I showed you. I think I installed Clickhouse in the beginning. No, maybe I didn't. So I installed Clickhouse like I did with my terminal. So I'm installing it here. Successfully installed. Now I'm just gonna run it here just to test it out. So we're gonna run Clickhouse. Let's see if this one is correct. It says house 0. I'm gonna see what the file looks like. LLMs, welcome. Yeah, okay. Yeah, sorry, it's taking a little bit of time here, but I should have ran these in the beginning. Yeah, but as you can see, like what I mean by like you can create a pipeline is that you have like a way to say, hey, create this query for me, create this, like I want to know something, right? Hey, give me this information. Then the LLM takes that and creates the query. then the query could be put in another step in the pipeline to actually be ran automatically, right? So you could have like a script or something running where you actually start that ClickHouse, pass in that query, and then give you the information all in one shot, basically. Yeah. Oh, hold on. It might actually be running. Oh, is it running? My bad. Okay. It is running. Sorry, I didn't really realize it. It actually, yep. So you see, it found the answer. So the query that it created, I just pasted it in the ClickHouse, and then it gave me the answer. Cool, right? We can try. We can try another one. Most crime at night. I'm trying to see if this one is good. Let me create this one. Oh, actually, I may have to kill maybe this one for now. And then, so I had to kill it because the other cell was actually running. So I'm gonna try to find complaint by crime type, and then recreate the query using that prompt. All right, so it gave me this. We'll see if it works. Looks a little. So offense contact count from this URL. I'm not 100% sure about this part right here, but we'll see what it says. Where times greater than 18, so after 6 p.m. Okay, let's see. We'll see if it works. Yep, so this one did not work because it's saying unknown identifier. So it's because of this. Yeah, so this one did not work. So yeah, it's a LLM for you. So sometimes it works, sometimes it doesn't work, but it's still able to sort of like comprehend. I'm gonna try the last one to comprehend the question itself. But then the nice thing would be to actually, let's say you run it and it doesn't work, to maybe like have like a loop back where if it gives it like a exception, then to come back and tell it, hey, this one did not work, pass in maybe the error code and have it try again.
Which model are you using?
GPT-4.
I tried the O1. I heard it's better.
Okay. Let me try it one last time.
Yeah, O1 or 4.0. I think both are better than the Turbo, I think.
Yeah. See, this one also errored out. Yeah. Let's see. But the first one worked. That we saw. Stop this. Do you know the name of the library, like the version? Is it let me just kind of like do this. Do you have the name of it? Oh shoot.
I think it's GPT-4 4.0, I think. Let me check. Yeah, I think it's GPT-4.0.
Like this?
Yeah, I think so.
Okay, let's see if it works, and if the syntax is still the same. Okay.
Yeah, and for the O1, it's just O1 dash preview.
Okay. Yeah, no, it's still. So it's not able to. You can't. It's like something to do with the way the query is written. But yeah, that's the. How do I say that? LLM is also not perfect.
So
But
one thing I noticed is that when you're using LLMs, sometimes they use the space and the return to line. So you might want to clean that up. That could break stuff too.
you mean, what do you mean, the space and line?
Yeah,
maybe-
so for example, when they do the select and all that, they might actually put a return to line somewhere that you can't see.
Okay, I'm gonna put it in my note here and see what it looks like. Because this is the query right here. Oh, okay. I think I know why. Yeah, I think I know why. Bear with me. So I'm just fixing the query here. Give me a second. What I think what it probably forgot to put quotation mark around the fields. That will not work. Let's see. How do I? Okay. Oh yeah, I think I know something else. Sorry. So I have it like in another page, so I'm fixing it and then trying to put it here. Now let's work. Yeah, I don't know if I have time to try to fix it myself, but yeah, basically the first query worked, but the last two, it was not able to get us a good working queries. So which means that, if you wanna, how do I say that? You could use, LLMs to do your things, but when it fails, you have to be able to actually look at the stuff and fix it yourself, So any other questions regarding this? I think that's really it that I wanted to show, really. It was interesting to go through this. For me, one of the takeaways is the way it does primary keys and indexes. Also, how you're able to query files like in a remote location without having to actually have them in your local machine. But again, it may not be as fast, Yeah, that's it. That's it for me.
So
Oh,
can you hear me?
yes, I can hear you.
Yeah, is that a tool that you're using on a daily basis?
Me?
I mean, regularly? Yeah, you personally.
No. I heard about it from Ben a year ago, and when we were talking about what topic we can talk about this week, we decided, maybe we can talk about Clickhouse, mostly because it's open source and it has some interesting features. But no, I don't use it personally.
Okay. It seems to me like a enterprise level type of product. So I thought that was something you were using. Oh wow, okay. That's great.
Yeah. It definitely, it's enterprise grade. I must say it may not be as popular, but there are a lot of companies. If you bear me, I'm gonna open up their page. We can see what companies are using it.
Yeah, I think a bunch of companies are using it, like Uber and stuff like that. I mean, a lot of companies that have that ingest a bunch of data and need to do some huge queries, almost real time. So it's used heavily, but it's not as popular.
Yeah, because the competition is pretty tough, right?
What would be, for instance, the competitors?
BigQuery is one. BigQuery is one. I mean, what are the data warehouses out there? I'm blanking out now on some of the ones. There's one from Amazon too, right? Who are the people who use Amazon? Well, let me pull it up. Yeah, even Databricks has a data warehouse. So interesting, right? When you do data warehouse tool, look at all the people that are paying to be on top. Starbucks is paying a lot of money from the Google search. Quill is paying. Databricks is paying. Look at our buddy, Clickhouse. Clickhouse is right there. Yeah. So yeah. So Redshift is what I was thinking. I think. BigQuery is the one that I've used a lot. I've used a lot of BigQuery. Snowflake, I think some people think use Snowflake as well, but that's like a completely different company. Snowflake and I think Databricks are competitors. Yeah, Databricks right here.
Yeah, I think if you go to the Clickhouse page,
website,
you should be able to see the customers, I think.
Yeah. Sorry, I was studying Clickhouse, taking the training. So. Oh, sorry, that's not what I mean. Clickhouse. Oh, yeah. So it's trusted by
companies.
Yeah, trusted by. I'm not really sure what it means, but yeah, Microsoft, Spotify. That means maybe like they've mentioned Clickhouse at one point or another. LangChain uses it. Twilio.
And usually it means that the company is using it. So
yeah.
Cloudflare. Okay.
Yeah. I would recommend to just try it. It's not difficult. So the ClickPipe that I've mentioned, you're able to ingest data from from like some of these sources, the integrations, MySQL, Postgres, and then the languages, right? Python to query, right? Go, Ben's favorite, Rust, another Ben's favorite, JavaScript, another Ben's favorite.
Like getting ones. So
yeah, I have a lot of favorites.
Yeah. So remember when I was talking about row oriented and column oriented? So this is like the kind of like an illustration for it. I don't know if you can see what it is. So like when it's doing a row operation, it has to go like flop, like through rows. When it's column, it just needs to figure out which column it needs, and then it's able to give you that information right away. Yeah. That's it.
Yeah, it seems to me that the main benefits is that this one can scale like very, very far.
Mm-hmm.
you know, and then at the same time, it's a flexible tool that you can just run on your machine or your own VM and stuff like that.
Yep.
You know, whereas some of the alternatives, you have to have a cloud subscription and use it from there.
Like you cannot download BigQuery into your machine.
Exactly.
Right?
Exactly.
Databricks, you know, Apache Spark maybe, but the platform itself, Databricks, you have to use the the cloud hosted one. Whereas this one, you know, if you are you know, as you mentioned, if you are maybe starting out and you want something that's flexible, Clickhouse may be able to help you with that.
Yeah. Plus, the way that it's distributed, like you mentioned earlier, if it's a single binary, you know, it's even easier to install that than, let's say, like MySQL or Postgres. You know, it's just a single file. So it's very, very flexible for a bunch of use cases.
Yeah. I think Afis was asking something about minimum, right? Yeah, I think this might be good in terms of pricing. But that's usually like production grade, right? Yeah, right here. You can put it on all three, AWS, Google, and Azure. Yeah. That's it, guys. Any other questions, comments?
Just to say thank you again.
Oh yeah,
for doing the hard work for us.
Yeah, no, this one was it was going back again to working with data, and especially data quality. Right, you run your query, you run into an issue about data quality, you have to go fix. You know, fun times. Yeah, well, thank you everyone. I think we're like perfect timing, 11:30. So yeah, if you have any questions, let us know. But I think it will be posted. The talk will be posted like on our website soon. So yeah.
Yeah, it's already there. I think let me share the link again.
Okay.
Yes, this one was on time. Hello, Hafiz.
Hafiz taking a stray bullet, man.
Yeah, don't let Hafiz do the
Yeah, yeah.
I promise the next one is going to be shorter.
Yeah, I think Hafiz holds all the